Hi, this is an example problem from Chapter 7 on an elastic collision. Pause for a moment and read the question. So as usual, we've gone ahead and divided the before and after here. So we've got your before up above and you've got your after below, and you can see initially the two objects are coming together. And afterwards they've collided and they're moving apart. Now the picture here is a little bit different than what the problem statement says. It says the balls have identical mass, right? So in reality, M1 is equal to M2, right? And so those two balls are really the same mass. So we'll remember that. Finally, when we're going to solve an elastic collision problem, right? It's a collision, so we know there's the condition that the total momentum of the system initially will be equal to the total momentum of the system final. Let me change that to an I just because they use I here for this. All right, so our notation matches theirs. Now this first statement here, which is true for all collisions, of course, is called the conservation of linear momentum, right? Now in an elastic collision, we also have the conservation of kinetic energy as well. So whatever the initial total kinetic energy is, the sum for the objects in our system, it's going to be the same when we add up those numbers in the end. And of course for our system here, it consists of just two objects, ball 1 and ball 2, right? Now these two conditions together, if we plug them in, we can set up a couple equations for all four of the velocities here. So this one, this one, this one, this one, and the two masses. And if we do that, don't worry about trying to do it yourself unless you want to have some mathematical fun. But I've got an equation for you where we've used the two conditions. You can see them here. And we've solved for the final velocity of the first object, the final velocity of the second object in terms of the initial velocities and the masses, okay? So we're going to go ahead and just copy those and paste that equation in. All right, so we know a lot of the values here. We know what the initial velocities of the balls are, right? So those are given to us. And we also, well, we don't know what the masses is, but we can actually do some simplification here. So let's look at this first mass term here. If the masses are the same, then we can cross out all the 1 and 2's, and m minus m, whatever the mass is, right? These two are going to cancel out to give you 0 here. So that whole term is gone. And by the same logic, these terms here, m minus m, whatever it is, the numerator is 0, that whole term is 0, right? Finally, let's look at the other mass term here. These are all the same, right? So I got 2m divided by an m plus an m, right? In other words, this is 2m divided by 2m. That just equals 1, right? So actually, the only thing we have left here is velocity of ball 2 initial. And by similar logic over here, this whole thing, that equals 1 also. 2m divided by 2m. And we're going to end up with this value. Only thing left is a v ball 1 initial. And so we can put those numbers in here. We got to identify. So the initial ball 1, right, that's going in the positive direction. So that is your plus 30 meters, plus 30 centimeters per second, right? And your ball 2, it's the one going in the opposite direction, right? It's got the negative, right? So here's your V2 initial right here. And so I'm going to put that in. Minus 20 centimeters per second. And for v1 initial, we said that's this one here, the one that's going in the positive direction. So this is going to be a plus 30 centimeters per second. And so if you look what happened here, after the collision, these two balls, they've both reversed directions, and now they have the same speed but opposite directions. They basically flipped their velocities, right? So v1 final is equal to minus 20 centimeters per second, right? Which was the initial velocity of v2. And v2 final is equal to a positive 30 centimeters per second, which was the initial velocity of ball 1. You have a similar problem in your homework where the masses actually aren't the same. I believe they're given values, so you would need to plug those values in. Remember to draw a before and an after picture and carefully identify which of the velocities go with which of your objects in your picture.